The CAF-FCH2RAIL project was selected by the Clean Hydrogen Partnership and co-funded by the European Union to boost the development of hydrogen technologies in rail. The demonstrator train was the first hydrogen-powered train to be tested on the Spanish railway network and successfully completed the journey from Zaragoza to Canfranc in June 2023. This journey marked an important milestone in the project. It was only the beginning. There was more to come. The train has continued dynamic testing to simulate the commercial service on 6 additional lines over a period of 10 months. These lines have been arranged around 3 locations: Zaragoza, Madrid, and O Porriño, Pontevedra. The first tests have been carried out based at CAF's facilities in Zaragoza. First up has been the route from Madrid to Soria, a 246 km line with high electrification degree, which makes the bimode demonstrator train the ideal solution. Here, the tests have focused on the non-electrified 94 km section between Torralba and Soria. The tests have been conducted at high altitudes above 940 meters and reaching the highest value of these 6 lines, 1,160 meters. The Zaragoza-Teruel line is a longer line with 174 kilometers not electrified. This is a demanding route, reaching a maximum altitude of 1,055 meters and featuring differences in altitude up to 750 meters during the route and steep gradients of 20 thousandths. And all this in winter conditions of up to -3°C with ice and snow. At the end of these journeys, the test base has been moved from Zaragoza to Madrid. On the Madrid-Talavera route, a short section of 137 kilometers, the tests have focused on the non-electrified 112-kilometer section. The most characteristic feature of this line is the highest average speed of around 110 kilometers per hour during testing, reaching the maximum speed of 120 kilometers per hour. The route also features a demanding profile, with steep gradients up to 20 thousandths, with differences in altitude over 300 meters, reaching a maximum altitude of 684 meters. The Madrid-Cáceres route is an extension of the Madrid-Talavera route, providing an opportunity to test the demonstrator train on long-distance services. The main objective in this route has been to validate the range, but this line presents additional challenges, including very steep gradients up to 23 thousandths and differences in altitude up to 500 meters. The autonomy challenge has been scheduled first to Cáceres, demonstrating a range to 616 kilometers. A further stage to Mérida has been added, meaning the train has covered a total of 804 kilometers with a single refueling, marking a significant milestone. Then, the testing base has been moved to O Porriño in Pontevedra. The arrival of the train in Portugal has marked a major milestone. It has become the first hydrogen train on the Portuguese Railway Network. The tests have been carried out on the Minho line from Valença to Nine, requiring an autonomy of 180 kilometers. The line features partially along the coast, with a gentle profile. The Ourense-Santiago line is a 100% non-electrified line of 130 kilometers. During the testing on this line, the train demonstrator has climbed steep gradients in a line, also featuring significant differences in elevation up to 450 meters. The arrival of the train in Santiago de Compostela in April 2024 has marked the end of the service experience of the train demonstrator. After running 10,000 kilometers in hydrogen mode, as well as 6,000 kilometers in electric mode, the demonstrator train has successfully completed over 37 days of dynamic testing. Approximately 2,200 kilos of hydrogen have been consumed. The project's objective of extending the use cases for fuel cell trains has been achieved. The tests have been a great success, and the partners are proud of the results.
The lines selected for the test were identified as representative by the project partners. These routes have been a big challenge due to the very demanding orography, not comparable with other lines on which hydrogen trains have been tested to date. The operation of the train has been very robust and reliable, and the results have been utterly satisfactory in terms of performance and autonomy. The best professionals have been involved in the test team in order to achieve all the objectives. The demonstrator has been a laboratory that has provided key information for better understanding the application of hydrogen technology to railways.
We are happy with the successful completion of this project's testing phase. The results of these tests are very important for Toyota, as this is the first time the Toyota fuel cell modules have been applied to the railway. We have learned a lot thanks to the testing, and we will reflect these learnings towards future developments of our Toyota fuel cell systems.
These tests have allowed us to validate the models developed so we can reliably simulate the performance of the power pack under different operating conditions. An intelligent dash system has been implemented by CAF in order to achieve efficient driving, providing maximum autonomy while keeping the lowest hydrogen consumption. The advanced dash system recalculates in real time the optimal hybridization strategy between batteries and fuel cells to meet the journey time, and it has achieved significant hydrogen savings. After this test, we can confirm that the technology developed by CAF and applied in the demonstrator train has reached the maturity level necessary for its use in commercial service.
Hydrogen train technology has the potential to transform our railways, making journeys cleaner and greener by further reducing CO2 emissions. A promise of sustainability, economic viability, and customer satisfaction that, thanks to the CAF-FCH2RAIL project, feels closer today. Stay up to date and follow all the project's progress on fch2rail.eu.